Hello everyone. In the previous session, we understood what do we mean by a minimum spanning tree. Now, in this session, we'll understand how do we find that minimum spanning tree, or shortly called as MST, minimum spanning tree. And to find out, one of the algorithm used is Prim's algorithm. So how do we do it using this algorithm? We'll try to understand through this numerical example. So the example says, consider the following distance network diagram, which means the weights, whatever is given in the arcs, on the arcs 4, 6, 5, 6, these are all distance of laying telephone cable in a locality, which summarizes the distance network of the locality. The number on each arc represents the distance between the nodes connected by that arc. Find the minimum spanning tree, means which will connect the nodes of the network by a set of arcs such that the total length of all the arcs is minimized. So we are going to find out using this Prim's algorithm what is the minimum spanning tree. Network is given like this, and how do we proceed with the Prim's algorithm? Let us start with our solution. First step in Prim's algorithm is identify that arc which has got the least distance. 4, 6, 6, 2, 3, 5, 4, 9, 8, 10, 5, 7, 1, 3, 6, 3, 2. So the least distance is 1. So the corresponding arc is 7 to 8. 7 to 8, somewhere here it is coming. I will just copy similarly. I will draw the arc. 7 to 8. I will draw a arc connecting these two nodes or these two vertices. And the 7 to 8 is actually 1. After drawing this, we'll create two sets. One set S1, which will have these two vertices which already we have drawn, that is 7 and 8. And the other set will have the rest of the vertices, that is 1. We may notice that the least vertex number is 1 and the highest is 10. So all the other numbers I will be writing in the second set. 1, 2, 3, 4, 5, 6, 7 and 8 will not be written here because already it is there in set 1. So we'll write 9 and 10. After doing this, we'll try to find out the relation in the sense 7 to 1. 7, 1, 7, 2, 7 to 3, 7 to 4, like that. Means I will write like 7 to 1, 7 to 2, then 7 to 3, 7 to 4, 7 to 5, and then 7 to 6, 7 to 9, 7 to 10. So I wrote all possibilities from 7 to this set, from this element of this set to all the elements of this set. Then next is 8 to 1, 8 to 2, then 8 to 3, 8 to 4, 8 to 5, 8 to 6, 8 to 9, and then finally 8 to 10. Now let us check whether we have 7 to 1, means is there an arc connecting 7 to 1 in the diagram. 7 is here, 1 is here, there is no direct arc connecting between 7 and 1. So I have to put cross over there, there is no such arc. Similarly, 7 to 2, there is no such arc. 7 to 3, there is no such arc. 7 to 4, let's see, 7 to 4. 7 and 4, there is an arc connecting and the distance is 10. So here I will say 10 is the distance. Similarly, 7 to 5. Do we have it? 7 and then 5. Yes, there is a arc connecting it, which is having a distance of 5. So let me write there 5. Then 7 to 6. 7 to 6. 7 is here, 6 is here. Yes, there is an arc connecting it and the distance is 3. Then 7 to 9. 7 and 9. Yes, there is an arc. Distance is 3. Then 7 to 10. 7 is here, 10 is here. There is no arc connecting, so I have to put a cross there. Then 8 to 1. 8 is here, 1 is here. There is no arc connecting those two. I have to put a cross there. Similarly, 8 to 2, there is no arc. 8 to 3, there is no arc. 8 to 4, there is no arc. 8 to 5. 8 is here, 5 is here. Yes, there is an arc and the distance is 7. Then 8 to 6. 8 is here, 6 is here. There is no direct arc. So I have to put a cross there. 8 to 9. 8 is here, 9 is here. Yes, there is an arc, which is 2. Distance is 2. Then 8 to 10. There is no direct arc. So I have to put a cross there. So if we again look into this diagram, it is least is 1. Already we have drawn this. Now from this, which is the least? Here cross and all we can ignore. 10, 5, 3, 3, 7, 2. So 2 is the least. That means I can draw that particular arc. That is 8 to 9. So where is 9? Here it is. So I can put a circle here. That is the node vertex 9 and then join these two. Call this as 2. So this is done by us. So what happens to our new set? New set, not only 7 and 8, even 9 will be added in the S1, the first set. 7, 8 and 9. S2 will have the remaining vertices, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 will not be written, then 10. Already we wrote everything possible from 7 to all the numbers, 8 to all the numbers also we wrote. Now we have to write only from 9 to 1, 9 to 2, 9 to 3, 9 to 4, 9 to 5. Then I can write 9 to 6, 9 to 10. Now, is there a, what do you call, is there an arc connecting from 9 to 1? 9 is here, 1 is here, there is no arc connected. Likewise, most of them there is no connection. So 9 to 1 is not there, 9 to 2 arc is not there, 9 to 3 arc is not there, 9 to 4 arc is not there, 9 to 5 arc is not there. 9 to 6, you see, 9 is here, 6 is here, there is no direct arc. So 9 to 6 is also not there. Now 9 to 10, 9 is here, 10 is here, there is an arc and the distance is 5. So this distance is 5. Now, whichever is not cross marked, let us check the least distance now. 10, 5, 3, 3, This is over, 2 is over, so I should not consider 10, 5, 3, 3. Then here 5. That means the least distance is 3. So you may find if I put 7 to 9, if I consider this, what will happen is it will become a closed, means it will not be a tree. So I should not consider 7 to 9. Let me put a cross here. So what is left now is 7 to 6, which is 3. Where is 6? Above 7. So I will draw a vertex above, call it as 6, and then connect this 6 and 7. And the distance 7 to 6 is 3. So that means now when we rewrite our sets, set 1 will have 7, we added now 6, isn't it? So we will now write 6 also. We added 6, so 6, 7, 8, 9 will be written in the first set. 6, 7, 8, 9. So S2 will have the balance 1, 2, 3, 4, 5, and then 10. Already we wrote for 7, we wrote for 8, we wrote all the possibilities. 9, we wrote all the possibilities. Now we have to write only for 6. So 6 to 1, 6 to 2, 6 to 3, and then 6 to 4, 6 to 5, 6 to 10. Now let us check whether 6 to 1 is there or not in the diagram. 6 is here, 1 is here, there is no direct arc. So I have to put a cross there. Similar is the case for 6 to 2, there is no arc. 6 to 3, let us check 6 to 3. 6 is here, 3 is here, there is an arc and the distance is 9. Distance is 9. Then 6 to 4. 6 is here, 4 is here, there is an arc and the distance is 8. So 6 to 4 distance is 8. Then 6 to 5. 6 is here, 5 is here, there is no arc connecting those two. This will be cross. Then 6 to 10. 6 is here, 10 is here, there is an arc and the distance is 6. Now let us recheck the numbers, the distances, and identify the least distance. Now we have 10, 5. This 7 to 6 we already did, so I have to put a tick, sorry, which we did in the previous one. So 10, 5 is there. Here 7 is there, so 10, 5, 7. Then again 5. Then we have 9, 8, 6. That means the least distance is 5 now. 5 is occurring here, 7 to 5, and it is also occurring 9 to 10, 5, right? I can choose arbitrarily anyone. Either I can choose 7 to 5 or I can choose 9 to 10. Let me choose, what do you call, 9 to 10, this one. If I choose this, then there I will go and draw one more vertex for 10 and then connect this 9 and 10. And that distance is what? 9 to 10 is 5. So let me write here. 5. Now our set 1 will have what? Set 1 will have 6, 7, 8, 9 and 10. Set 2 will have the balanced vertices 1, 2, 3, 4 and 5. We already wrote for 6, 7, 8, 9. Only thing what we have to do now is for 10. So that means 10 to 1, 10 to 2, sorry. 10 to 2, and then 10 to 3, 10 to 4, and then 10 to 5. Now, do we have 10 to 1? Let me check here itself. No? 10 to 1 is not there. And then 10 to 2 is also not there. 10 to 3 is also not there. 10 to 4 is also not there. 10 to 5 is also not there. So none of them are there. Means no arcs possible like this. I have to cross all this. Now, again, from the weights available with us, we have to identify the least. So already when we did in the previously when we did in the previous iteration, we understood that 9 to 10 we chosen instead of 7 to 5. Now I can choose 7 to 5. If I draw 7 to 5, 5 will be something new. So that means 5 where it is here. Let me draw same way. Call it as 5 and join this 7 and 5. And we know this distance is 5. So we already marked 7 to 5. Let me put a tick there. So now our set 1 will have, apart from 6, 7, 8, 9, 10, we will also have 5. 5, 6, 7, 8, 9, and 10. Set 2 will have the balanced vertices 1, 2, 3, and 4. Now we already did everything except 5. So now we will do it for 5. 5 to 1, 5 to 2, then 5 to 3, 5 to 4. Do we have 5 to 1, 5 to 2, 5 to 3, 5 to 4? Let us check here. 5 to 1, yes, it is there. Distance is 3. Distance is 3. 5 to 2, do we have? No, 5 to 2 is not there. 5 to 3 is also not there. 5 to 4 is there. 5 to 4 is how much? 5 to 4 is distance 4. So I can write for 5 to 4, 4 distance. And the rest I can put cross now. Now, let us identify the least. 3, 4, then 9, 6, 8, then we have 10, 7. So till now, whatever numbers we had seen, we found 3 is the least. So what is that 3 here? 5 to 1 is there. Is that possible? Yes, it is possible. 1 is here. So I can put a circle over there for vertex 1. Join this 1 and 5. And this is 3. So that means we need to add in our first set 1 also. So S1 will have 1, 5, 6, 7, 8, 9, 10. S2 will have 2, 3, and 4. Now with 1, we have to identify the combinations. Now we need to identify the connections between 1 and whatever vertices are there in set 2. So 1 to 2, then I can say 1 to 3, and then 1 to 4. Do we have 1 to 2 in the diagram? 1 to 2, yes, it is there. 4 is the distance. Distance is 4. 1 to 3, do we have? 1 to 3 directly not there, whereas 1 to 4 is there. 1 to 4 is 2. So 1 to 4 is 2. This is not there. Now let us check the minimum weight. 2, 4, till now least is 2. I think directly we can check whether 1 to 4 can be joined or not. Yes, it can be, because 2 is the least. So I can, if we look into the diagram original, 4 is here. So let me draw 4 there. So what we did is we have drawn 1 to 4, and 1 to 4's weight is 2. So that means in our set 1, now we have to include 4 also. Set 1, we will include now 4 also. Set 2 will have the rest of it. So now from 4, we have to identify 4 to 2 and then 4 to 3. Check whether we have 4 to 2 arc or not. 4 to 2, yes, it is there. 6 is the distance. Distance is 6. Then let us check 4 to 3 arc there or not. 4 to 3 is also there, which is 5. It is 5. Now let us check the least weight or least distance. 5, 6. Then we have this 1 to 4. We have already done it. Let me put tick. 5, 6, 4, 3, 4. Till now 3 is the least. 6, 9, 8. Then 7, 10. That means 3 is the least. What is that 3? Actually speaking, 5 to 1. 5 to 1 is possible or not? Already we did 5 to 1. Somewhere I didn't put tick. This already we did, so I should not consider now. So now the least weight is 4, I think. So 4 means, is it 1 to 2, 5 to 4? 1 to 2, I mean 4 is the least weight now, because 3 is already done. So 4, let me check whether 1 to 4 is possible. Sorry, 1 to 2 is possible and 5 to 4 is possible. 5 to 4, if I do, it will become a closed. It will close, means it will not be a tree. So 5 to 4, I should not do. Let me put a cross here. Anything in having a weight 4, we will check apart from this 1 to 2. No, nothing is there. So only 1 to 2 is there. 1 to 2, is it possible? Yes, it is possible, because 2 is here. Let me draw 2 there and join this 1 and 2. One to 2, the distance is 4. So we have to add now 2 also in our set. First set. 1, 2, 4, 5, 6, 7, 8, 9, and 10. Yes, 2 will have only 3. Now we have to find out the combination, only one combination, 2 to 3. Do we have 2 to 3? We have to check. Yes, it is there. It is having a distance of 6. Now let us check what is the least weight. Here it is 6, then 5, 6, 4, 4 we have already done it. So 5, 6, and then this one is 6. Then here one more 6, 9, 8. That means least is 6. Least is 6. Which one should be selected? This is 2 to 3 is also 6. 4 to 2 is also 6. If we put 4 to 2, 4 to 2 means it will not be a tree. So I should not consider 4 to 2. This is closed. Anything else? 4 to 3. 4 to 3 is what? Already we did. 4 to 3. 4 to 3 is possible because that is 5. Anything else with 5? We have to check. Weight 5. Weight 5. No, only one weight 5 is there. That is from 4 to 3. Now 4 to 3, where 3 is located, here it is located. I can draw 3 here. 4 to 3. Join this 4 and 3. And the distance for 4 to 3 is 5. Now, our set 1, I have to add this 3 also. 1, 2. All the vertices now came into set 1 and set 2 became null set now. So we have to stop the process or the procedure or the algorithm. So this is our minimum spanning tree. Whatever we have drawn, we may notice all the vertices came 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can calculate the least weight or least distance for this spanning tree, or which is nothing but minimum spanning tree, is I need to add the distances 4 plus 2 plus 3 plus 5 plus 5 plus 3 plus 1 plus 2 plus 5. How much? 6 plus 3, 9, 9 plus 5, 14, 14 plus 5, 19, 19 plus 3, 22, 22 plus 1, 23, 23 plus 2, 25, 25 plus 5, 30. That is the solution for this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.